Welcome to the most significant research and news for creating your most beautiful, healthy life. And today we're going to look at the link between type 2 diabetes, insulin resistance in the liver. There's been some great studies on this, but it's really all about doing the things we need to do to create your most beautiful, healthy life, and just taking a look at what it is that really is the cause of this. And when we take a look, one of the things I'm going to go into some of the research on this. Let me just bring that up in a second. But the link between type 2 diabetes and obesity are so intertwined that we actually call it diabesity. And the cellular and the molecular mechanism by which obesity sort of predisposes the development of insulin resistance, they're really not understood well. In the University of Geneva in Switzerland, pretty much these were some top scientists. We're going to go to, let me see if I can bring this up here. And this was the research. You can see that it was just published online, November 28th of 2017. They had submitted it back in the end of July. But what they were looking at is really what was what's the purpose? Like, how is it that obesity leads to not just diabetes, but leads to not only type 2 diabetes, but also how does it lead to insulin resistance? And one of the things that they've showed is that the key role was played by the liver in the onset of the disease. And as they talk about here, this protein tyrosine phosphatase receptor gamma, that gene, and by the way, what that has been linked to, and they refer to that as PTPR gamma, which is increased with obesity, but it actually increases with inflammation. And that's the thing that we have to realize is that it increases with inflammation. And what they did was they wanted to look at this because as it increases, one of the things that they theorized, I should say, is that it inhibited the insulin receptors on the hepatocytes. So the cells within the liver, these hepatocytes, that it would inhibit the insulin receptors on that site. And so what the researchers did was they modified the genes to either overexpress PTPR gamma or to underexpress PTPR gamma, or just have normal expression of PTPR gamma. And so what they found was when mice completely were lacking PTPR gamma, when they were completely lacking this protein tyrosine phosphatase receptor gamma, they found out that no matter what happened, they could put them on a high-calorie diet. They could develop obesity. The mice would become obese, but what they wouldn't develop was insulin resistance. In fact, it seemed like they were protected from developing insulin resistance. In fact, they were protected really from, almost seemed to be protected from diet-induced diabetes. So it was very difficult for their diet to cause diabetes. And when they, let's get real here, the researchers, when they look at this stuff, they're looking at it from how do we develop better, more drugs? It's really all about, can we target, is there something that we can target? See, that's why the researchers always try to find out, like, what is it that we're targeting this one thing? And what they showed was that even when they affected the gut microbiome, because there's certain bacteria, there's certain microbiomes that produce obesity, but they also produce insulin resistance. So as that rises, it produces insulin resistance. What they found out was when they were totally lacking PTPR gamma, it didn't matter if they had the bacteria that would cause obesity, if they had the bacteria that would cause, and when we talk about the bacteria, we're talking about the probiotics in your intestinal tract, which is referred to as your gut microbiome. If they, no matter what, that this was an overriding factor for that. And they found out that even when they were at normal levels of PTPR gamma, they could still develop diabetes, insulin resistance. They could still develop the insulin resistance. So they're looking at how do we underexpress that? Well, here's the thing. It appears that you need a multiple, and when I look through that study, and we put that study back up, you'll be able to see, and you can go to it. You can, let me see if we can bring that up here. You can go to it. It's Nature Communications, hepatic protein, tyrosine phosphatase receptor gamma links obesity-induced inflammation to insulin resistance. But I want to go through a little bit more on this because here's the thing. If we go up to, and this is another article from Scientific Reports, elevated fibroblast growth factor 21 in the obese insulin-resistant states is normalized by this synthetic retinoid fenretinide in mice, and that was, they call it fen. But let's just go to this, and what they're saying is that there's things, see, everybody's trying to find a different drug that can sort of normalize. Let me just go and show you this. And I've talked about this before. Molecular hydrogen improves obesity and diabetes by inducing hepatic FGF21 and stimulating energy metabolism in knockout mice. And what they showed here, and you can see at the bottom right here, it talks about the fact that when they drinking molecular hydrogen water improves obesity and metabolic parameters at the molecular level. We examined gene expression profiles, found enhanced expression of a hepatic hormone, fibroblast growth factor 21, FGF21, which functions to enhance fatty acid and glucose expenditure. Indeed, molecular hydrogen stimulated energy metabolism is measured by oxygen consumption. The present results suggest the potential benefit of hydrogen in improving obesity, diabetes, and metabolic syndrome. Here's the thing. We can also go, oh, and I thought I put this up here, and I guess I did not yet. If you look up curcumin, in the curcuminoids, which we know affects the liver, which we know affects CYP, which we know affects different, the P450 pathway. One of the things, it decreases inflammation. What we see is a common factor here, that it's reducing cellular inflammation. And when we reduce cellular inflammation in the hepatocytes, particularly in the liver, then we dramatically improve this whole concept when we're dealing with insulin resistance. And here's the thing. These insulin receptors, the leptin receptors, and I'll go as far as saying, and even possibly the FGF21 receptors are affected by the hypothalamus. And we know that we can affect that with molecular hydrogen. That's what this is all talking about with FGF21 may be the key factor, I believe. You know, they're looking here at this PTPRY, you know, the protein, tyrosine, phosphatase, receptor gamma. You know, it's a mouthful, but all of this really comes down to inflammation, reducing inflammation. So one of the things with, for instance, what we've always started off with, one of the reasons why NutriMost was the first to ever have molecular hydrogen, the first to actually bring this tablet to market, the very first to ever bring it to market. We've always concentrated on the liver. We've always concentrated on reducing inflammation. We've always concentrated on the foods. What are the foods that are going to decrease inflammation for that particular individual? You know, for instance, you know, with one person, broccoli is not good. With somebody that has Crohn's disease, for instance, we know that broccoli helps soothe the inflammation at the endothelial cells in the intestinal tract. So we know that that is a positive for that. Okay, so there are certain things, when you understand how all this works, when you understand like the PPAR with these peroxisomes within the mitochondria, it's so much is about the mitochondria. We're going to do a lot more in the future on the mitochondria and how you increase cell function with the mitochondria, but what you're going to do is you're going to decrease the inflammatory response. So one of the reasons why NutriMost has been so big in saying, hey, let's heal the receptors. And a lot of that becomes part of the fact that the hydroxyl radical and these inflammatory free radicals, the inflammatory cytokines, for instance, interleukin-1. We know that, for instance, even this one here, this PTPR gamma, one of the things is we know that that influences interleukin-1. So what do we do with that? So the processes, and that's why we have been so involved with using, let's take a look at the foods, let's take a look at all the clues the body gives, let's do a root cause analysis and say, okay, when should we be affecting the liver? And when it is, what are we going to use? We have for instance, we have our product HepatoMost, and we have our product CurcumaMost, which is one's the liquid, and one is a capsule. And so there's times for the one, there's times for the other. And we use and you're constantly using research, like this research. You're constantly using the known, not only known research, but what is our clinical observation? Some of that is anecdotal, because you're saying, okay, I had patients that had this condition. I did this on some. I did this on the other. What worked? Well, it worked before. I'm going to do it again. Did it work the next time that I did it? And so that's how we develop all the information with our NutriMost intelligence. And we've put a lot of time, money, energy, effort into creating this. And I just think it's great. But one of the reasons why I like to always, the reason why we do these programs. And by the way, just so that everybody knows, this program is always on every single Thursday from noon. It starts at noon. It's usually just a quick research, some of the most common research. We're going to put many more of these out. They're just short, brief things. But really, you have to understand there is a link between type 2 diabetes and your liver. And so it's always about clearing the liver. It's always about, and sometimes in order to clear the liver, you have to clear the common bile duct, because that's what allows bile and all these byproducts from the liver to pass from the liver down to the intestinal tract. And if you're not being able to get it to the intestinal tract, then it backs up basically. And that's what you'll see. I talked about this last week. When bile goes through the body, you'll see the liver spots, for instance. And in that case, you would not use either CurcumaMost or the HepatoMost as your primary supplement. You'd want to use GBMost, which is for the gallbladder. And people who have lost their gallbladder, they're actually the ones who need it the most, because that tells us that if you had an issue with the gallbladder, it's because you blocked the common bile duct. And if you block the common bile duct, we need to correct that. So a lot of times that's a loss in vitamin B6. But we use our GBMost has our gold coin grass herb as a key product in that. It's been shown to help with these bile precipitates. But one of the things is that you'd also want to raise your zeta potential. To do that, we would make sure you're getting sunlight into your body, because that's the energy, the photons, which we'll be going over that as well. And it's also allows an increase in zeta potential by grounding. That's the Earth is the largest free surface of electrons. So those are the things we can do. And if you have insulin resistance and suffer from that, we recommend looking into the NutriMost programs. But let's look at the liver. Let's take care of this. Let's help heal these various receptors, including the FGF21 receptors, including the PTPR gamma receptors as well. All right, look forward to seeing you. And remember, we have a program every single Saturday from 9 a.m. to 10 a.m. on NutriMost.com, Facebook.com, NutriMost USA. Go to the NutriMost USA on Facebook.